Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to the second lecture of Module 3 on physico-mechanical attributes of geoground or geomaterial. In previous lectures we have discussed about the concept of rock, rock material and rock mass in detail. Then we have discussed in previous lecture about the stress strain characteristic, some important mechanical parameter, concept of strength, strain, modulus and Poisson's ratio, mode of failure in brief, to make the things easy for your physical understanding and for physical discussion. In this class, we are going to elaborate about physical properties or physical attributes of rocks which are going to influence the mechanical response of rock. In this module, physico-mechanical attributes of geoground or geomaterials, today we are going to discuss about some common physical attributes of geomaterial. In this we are going to cover about geomaterial and category of different geomaterials, then about internal structure in brief, and some common physical attributes of geomaterial, particularly rock, and then influence of this mechanical as well as physical characteristic on our future discussions. Friends, as you know, the rock, we have discussed a lot about the rock. The rock is made up of different mineral constituents. Different mineral constituents. Among the grains, sometimes there is one gap here recognized as white. This zone is recognized as white. The overall response of this with respect to external observation as well as with respect to external forces depends on the arrangement of these mineral constituents in rock and traversed by some discontinuity if present. So about the discontinuity we will discuss later on. We are here today, we are going to discuss about the response of rocks in point of physical aspect. This physico-mechanical response of ground depends on this physico-mechanical attributes of geomaterial or geoground. As the name indicates here, physico-mechanical, then this physico-mechanical term, this physico-mechanical made up of two words, physical and mechanical. Physical attributes are physical property. We have different type of physical property. Here I try to enlist some of the physical properties are going to influence mechanical response, which we are utilizing in engineering geology. Another physical properties, common physical properties we are practicing in geology from our beginning classes at level of graduation, undergraduations. The major physical properties in general describes about, first point, form. Second point about color. Third point about streak. Fourth point about luster. Fifth point about hardness. Sixth point about cleavage. 7 point about fracture. 8 point about some special property. And partially we are utilizing here specific gravity. These parameters are useful for selection of geomaterial from different commercial point of view. This help in identification of rocks and minerals. Form is related to the form of natural rock or minerals. It is a tabular form, or it is a platy form, or it is a flaky form, or it is a banded form, or it is foliated form. The color is the look of rock or minerals by which we are going to identify, for example, sandstone, pink to grayish to earthy depending on the composition. Then limestone, grey color, whitish grey color, like this. So after observing this, color is going to help for identification of rocks and minerals. For example, basalt, dark greenish color, amphibolite, dark greenish color, some laterite, brown reddish color, bauxite, light brown color. So with help of the color we are going to utilize. Next is streak. Streak is nothing, it is the color of powder. Color of powder of rocks are mineral. So on the basis of history, we are going to identify some of the rocks, some of the minerals, etc. Luster is a degree of reflection of light. Some rocks or minerals are able to show high intensity or good reflection, vitreous reflection, some resinous reflection, some pearly reflection. We will discuss in next class about the summary. These are hardness. This hardness is actually relative hardness. Relative hardness. Here, for determining this hardness, we are going to compare one rock with another or one mineral another, and on the basis of different relative hardness, we have arranged 9 and 10 minerals for identification of hardness under Mohari scale. Then cleavage is natural fractures, the natural weak planes along which we are going to split rock or mineral easily. Then fracture is the natural tendency of the surfacial feature of any fractured rock. And then special property, sometimes some of the rocks showing a specific magnetic property or some piezoelectric property and others. And specific gravity, this is all related to the mechanical aspects. Porosity also related to mechanical aspect. Permeability also related to mechanical aspect. So in this class, we are going to discuss the physical property which are going to influence the mechanical response or mechanical attributes of rocks. Common physical attributes of rocks and soil such as specific gravity, density, porosity, void ratio, permeability, absorptions, and few more are important physical attributes of both rock and soil, and which are going to influence the mechanical response of rocks and soil. So these are mainly common physical property which are going to influence the mechanical attributes of rock or mechanical response of rocks as well as soil. We are going to utilize as specific gravity, density, unit weight in engineering. Unit weight we are going to utilize in case of engineering works. Then porosity, absorptions, compressibility and permeability. This compressibility we have taken especially for the soily ground, because our geoground is made up, as several times we have discussed, geoground is made up of both rock and soil. Here the rock is one of the component of the geoground. The further this rock may be present in form of rock, present in form of rock strata, present in form of soil mass or soil layer, if we are going to see about the difference between rock and soil, this difference between rock and soil principally depends on the compressibility. Compressibility depends on the arrangement of constituents. Arrangement of constituents. Due to arrangement of constituents, there is a changes in arrangement of the grains and the availability of the voids or pores. And this availability of voids or pore and mineral constituent that we are going to recognize as the constituent and arrangement of the constituent in form of texture and microstructure. In this way, we are going to see the rock is different than the soil. Here you can see some of the photographs. This is the rock grains supported by some finer materials. The sum of the portion you can recognize as the gaps. Here you can see some microscopic gaps here due to arrangement of this type of material, So these photographs representing the arrangement of the mineral constituent in different fashion in different type of rocks. You can see here the gap in case of soil. Soil gaps we can recognize easily. Here gap you can recognize easily. These words differentiating soils from rock. Due to presence of this word, the compressibility, these are compressible component. It means the degree of compaction in case of rock is more and the degree of compaction in case of soil is less in comparison to rock. So one by one we are going to discuss about different property. First we are going to discuss about the density. Density, very simple. Density of any material is defined as the mass per unit volume. Mass per unit volume, very simple. If we are able to know the mass of any rock, then we are able to calculate density. As the unit, it is important to use in case of the kg per m cube or ton per m cube or this gram per cm cube. The density of a rock is derived by practically dividing the weight of a specimen by its volume. Technically, we are going to weight this volume and going to modify these things with help of some concept of G and others. Actually, the density is the mass per unit volume. So volume we can going to recognize. We can going to recognize mass from the weight. The density of geomaterial consisting of rock is the same as specific gravity when expressed in metric unit, but when we are going to discuss about the relative concept of the density, then we are going to define specific gravity because we are going to measure this specific gravity with respect to water. It is determined as same way as specific gravity. Specific gravity of rock is defined as the ratio of weight of rock pieces at a given temperature to the weight of equal volume of water. Due to relative appearance, what happens? The unit of volume of water and this rock concept is going to illuminate the units. Therefore, this specific gravity has no unit. For example, if a rock granite having the specific gravity 2.68, then the density we can write here 2.68 gram per cm cube or 2680 kg per m cube or 2 in tons also we can recognize. The variation of the density in different type of rocks depends on the porosity of rocks. In case of igneous and metamorphic rock, in which the pores are negligible, the apparent specific gravity is almost same as the true specific gravity of rock, or apparent density is almost same as the true specific gravity of rock. But in case of porous sedimentary rock, the apparent specific gravity will vary to a certain extent depending on the volume of the pore. In highly porous rocks, this apparent specific gravity and true specific gravity or apparent density and true density are far different. It means density also depends on the porosity indirectly. The pores are more, density is less. Density less, pores are more. It means we can say that this density have porosity. This inverse relationship, one is increasing, another is decreasing. Another is decreasing, one is increasing. Next property, and concerned to this, here formula wise again I try to attract your attention. This density is m by v presented in gram per cm cube, and this is simply the density of a rock specimen dividing weight of the specimen by its volume. Other things we have already discussed. If we are going to classify density, then we can categorize this density as a dry density, as saturated density, as a grain density, as a bulk density. Dry density, saturated density, grain density and bulk density. Very simple. Dry density is the weight of dry specimen with pore free of water per unit volume. Very simple. Saturated density is the weight of rock specimen soaked in water per unit volume. Where the grain density is the weight of the powder of rock samples with respect to volume, that is per unit volume. If we are going to see here this relationship, mg by vg, where mg is mass of grain and vg is the volume of grain, in this way we are going to recognize the grain density. The distribution of this grain density here in a porous sedimentary rock, saturated density varies to a great extent from dry density due to pore spaces. If the pore space is saturated with water, the density is different. If empty pores, then the density is different. And the mechanical response of rock, that is the strength of rock, also reduces when its density reduced due to presence of voids. Indirectly we can say that the strength or mechanical response or strength increasing when density is increasing, decreasing when density is decreasing. Not always true, but often. Bulk density, as the name indicates, bulk density is defined as mass of a unit volume of geomaterial or rock. It depends upon the mineralogical composition, porosity and amount of water present in pore spaces or voids. If a bulk volume of rock specimen, that is the Vv, that is the pore volume Vp plus grain volume Vg. Here I try to attract your attention here. The simple diagram is going here the grain and here the pores. This is a pore and this is a grain. So pore volume, this volume and grain volume we are recognizing as bulk volume. Bulk volume, that is the pore volume, V pore plus V grain. What is the volume covered by this grain and what is the volume covered by this pore? And this bulk specimen mass we are going to recognize MB plus mass of water in pores. So bulk mass bulk is due to the bulk specimen mass is the MB plus mass of the water in pore, or this mg plus mass of the water in pores, or the bulk mass. This bulk density is the ratio of the bulk mass divided by bulk volume. Bulk mass is nothing. Bulk mass is nothing. It is the mass of grain plus mass of water present in pore divided by volume of pores, but volume of grain, or volume of grain plus volume of pore. In this way we are going to calculate bulk density. Here we have some condition. If rock is completely dry, then the dry density of rock PDR, which is the mg by Vb, where the V is the bulk and M is the grain mass. Then we can say that this bulk density is changes in form of this dry density. Because here we are adding this mass of the water and here volume of the water, volume of the pores. These two we are going to cut. Then this resulting density is equal to dry density. So bulk density can be converted as dry density if the pores are empty. If the sample is saturated with water, then saturated density of rock we can recognize PV is equal to mg plus Vb into rho W by Vb. So mg, the mass of the grain, plus volume, bulk volume, into the rho of water, here the present, and then the bulk volume. If we are going to remark this, then usually the dry density of rock is estimated and cited as one of the rock parameter unless otherwise specified. The density of rocks depend on the porosity, the discontinuity and other open spaces inherited in rock or rock strata. For the same rock type, the density increases as the depth increases due to decreased frequency of the open crack or pores or closure of cracks and others. This type of variation of the density with respect to depth depending on the nature of rocks also. In case of sandstone, it is different. In case of shale, with respect to depth, different. These aspects generally utilized by geophysicist persons during or petroleum engineering persons during the logging concerned to the change of density. Weathering of rock near the outcrop decreases the density due to fracturing, and secondary due to increase in volume of certain minerals as a result of decomposition. Here they can come in contact with the water, for example, Montemorillonite and anhydrite. And thirdly, due to decomposition under the influence of atmospheric action in form of, for example, alteration of feldspar into clay mineral under the action of water and carbon dioxide. So weathering is also going to influence the density. So these are the factors going to influence about the density. Next is the porosity. Porosity is a very important parameter going to influence mechanical response of rock as well as hydrological response of rock. The porosity of rock is defined as the ratio of pore volume. Ratio of pore volume, volume of the internal pore spaces, interstices and voids to the bulk volume of rocks. It is simply Vp by Vb. This Vb is representing bulk volume and this Vp is representing pore volume. P for pore, B for bulk. So the porosity we can recognize Vp by Vb, and then this Vp depends on this pores, and this Vb is a summation of both, because we have already discussed made up of grains and pores. So this bulk volume is the bulk volume due to grains and bulk volume due to pores. So this relationship is important for estimating porosity if some values are given. The porosity can also be expressed in terms of grain density or dry density of rock, because the density we have already discussed have relation, this type of relation or this type of relation. Then N can be estimated in view of this, the density of grains minus the dry density, and related to grain density. In this way also we are going to estimate about the porosity indirectly, not directly. The factor influencing the porosity, the major factors which are going to influence the porosity of the rocks or soil is the size distribution of grains, shapes of grain, solidity of grains, opension of the grain and degree of the grain. Opension is orientation of the grain and degree of compaction. These parameters of the rock is going to influence about porosity. The porosity of different type of materials is different, depends on the availability of the pores. Similar to rock, density and porosity are interrelated. You can develop for different relationship for different rocks and others. Here some correlations we have discussed, and this correlation based on regression lines you can also develop based on data of porosity and permeability for the same rock. The next property is the water content. This is also depend on the pores. The water content of a rock is a ratio of mass of water in the rock pores or pore spaces or void to the mass of perfectly dyed specimen. In this way we are going to determine the water content present in pores. Very simple. This depends on the availability of the voids or pore. The saturated water content when the pores are fully saturated is the ratio of mass of water in rock pores at saturation to the mass of a dry rock specimen in terms of the previous descriptions. This presented in form of percentage. Another term we are utilizing, voids index or void ratio in engineering, and this assessment is known as void index. So void index is nothing but a measure of porosity of rock, and it's extensively used as it is used extensively as the primary characteristic of rock material in engineering geological or engineering applications. It should only be determined for rock that do not appreciably disintegrate when immersed in water. If the rock is soluble in water, then the determination of the water content is very difficult. For example, rock salt. Good example. Rock salt is soluble in water, therefore the water content present in rock salt cannot determine truly and practically. The void ratio, you are well familiar, volume of the voids with respect to the volume of solid, and the void ratio we are going to utilize similar to the pore ratio and others. Next very important parameter is unit weight, and unit weight is widely utilized in field of geotechnical engineering and civil engineering and for engineering geological applications. It is the same as we are using in case of density, same, everything same. Here we are recognizing the unit weight of unit component of the rock or unit rock. In civil engineering work, it is able to use the term unit weight for different type of calculation related to unit weight of concrete, unit weight of water, unit weight of brick and others, mortar and others, which is the same as density when expressed in unit of metric system. There the unit weight of some rock like basalt, suppose specific gravity 2.65, then density is 2.65 gram per cm cube. So the same way we are going to recognize here the unit weight. In English system of measurement, we have expressed the unit weight in terms of the pound and feet and others. Absorption is another parameter. Absorption is the ratio of weight of water similar to the water content filling in the pores in case of rock specimen to the weight of the dry specimen expressed in percentage. In this way, a rock specimen kept immersed in water for sufficient time may not absorb water to fill all the pore spaces of rock due to air in pore spaces. Therefore, for example, some clay present in pore spaces may swell when the specimen immersed in water and hinder entry of water into the pores. Therefore, some of the pores present in sandstone are present in other rocks where clay is present in pores is not going to allow for fully saturation. Thus, absorption is not essentially dependent on the total volume of pore spaces in a rock specimen or rock pieces, but depends on its capacity to absorb water. The rock with high absorption value are generally low in strength, so indirectly the absorptions have one relationship with strength. In certain cases, as we have in this absorption contest we have discussed. The clay present in pores is showing some swelling. So what is the swelling? The certain rocks which having clay minerals or clay-like mineral are found prone to swelling. Are swelling induced cracking and disintegration when exposed to short-term weathering process of swelling and drying. Placed in excavation mode, and due to swelling there is increase in pressure depending upon the wetting and drying cycle. The swelling is actually characteristically depends on the availability of the moisture content and inherent parameters of the rock like grain size, nature of bond between the grains and the chemical response of the grain material. The size of pores govern the capillary action, suction pressure develop, and perhaps also the osmotic suction and gravitational. The suction is another, that is the capillary action also important. Here the swelling is a very important because the swelling is going to increment the load on foundation, are going to enhance the load on the support system of tunnels or any excavation. So therefore swelling potential is a very important for engineering geological applications. The swelling strain, due to swelling there is a formation of strain that is recognized as swelling strain. And here one example, here we are going to see the swelling strain in Mount Morillonite. If we are going to evaluate, then VB plus VSM by VM, where VB is the volume of voids within this rock or soil, VLW is the swelling deformation under constant vertical pressure, and Vm is the volume of Mount Morillonite within the soil or within the geoground. It was assumed that the swelling of soil is due to the hydration of the Mount Morillonite. This concept was given by the Comini in 2004. That you will study at your advanced level. Particularly for the, not more for rock, but for soil or unconsolidated materials, the compressibility is a very important parameter, and on the basis of compressibility we are going to judge which material is rock, which material is soil, which material of the soil belonging to the good for the foundation, which type of soil belonging to the inferior for the foundation, etc. Compressibility is an estimation of the relative volume change of solid, or here we are more concerned about size, not fluid, in response to stress change in stress condition. For example, for a given mass of geomaterial, an increase in stress change more than 0 means some change, suppose here change is 2 MPa, will cause a decrease in volume. This delta change, delta here change in stress is a resulting change in volume. So this compressibility is going to determine minus 1 by V into change in volume with respect to change in stress. Delta V by delta sigma, where this beta is indicating about the compressibility, V is the volume and sigma is the pressure or stress change. In this way we are going to calculate about the compressibility, how much level a soil or a material can be compressed. So, we have discussed about some important physical property or physical attributes of rock which are going to influence the mechanical response of rock. This material you can see from this very interesting book, Introduction, or any rock mechanics books, and any engineering geological book. They all have described about the porosity, permeability, specific gravity, and one thing we left, permeability is interconnected voids allow for movement of the water through a medium. It is a property of medium, property of rock or property of soil. So friends, now we are going to conclude. The density of rocks and soil both depends on the composition, compaction and arrangement of the constituent, that is recognized as texture. The unit weight in an engineering parameter and same as density we are utilizing for engineering purpose. Specific gravity is a type of relative density without unit. Density has close relationship with porosity, as we have already discussed. Void ratio is a similar kind of index close to porosity. And water content is close to absorption, depend on the porosity. These physical attributes impart pronounced influence on mechanical characteristic of rocks and soil. In this class, we have discussed about concept of physical, mechanical property, particularly stress on physical property of rocks or soil, which are going to influence the mechanical response of rocks and soil or geoground or geomaterial. Next class, we will discuss about the mechanical response of rock. Till date, we have developed a concept regarding the physical attributes, regarding different type of geological agencies performing as a water-rock interaction and others, different type of geomorphological features useful in engineering geological applications, and in this we are going to move towards change of the geological information from qualitative to the quantitative. Thank you.